how AI is being used uh, right now in the cybersecurity space and how we can get to doing stuff in a much more efficient manner. And finally, I'll close it off with sharing what we are building in this particular course. So, just to quickly sum things up, right now, what we see is a very uh, compressed time span for attackers who are getting started on an attack surface, right from initial access to data exfiltration. It has grown 4x in the past couple of years. Uh, the initial access vectors used to be brute force, which has now been upgraded to password spray and now is totally across the board with stolen credentials, MFA abuse, as well as finding out IAM misconfigurations. And it will continue to do so because the ability for an AI system to automate all of these processes has made things much easier. The same goes on for figuring out multiple attack surfaces and where can the attack vector be. Now, this has led to a lot of visibility within organizations about misconfigurations. The most recent example you can take is of Mythos model, which was released by Anthropic. Many people panicked initially, but the closed beta group got access to it and they found a lot of things which they worked on fixing and are currently still working on. So this brings us to the next thing, which is how would AI imply in our lives as defenders and probably as attackers? Well, from the attacker perspective, it is pretty simple to assume they can write scripts, they can write their own programs, they can automate things, they can create their own playbooks. Spinning the same thing for us defenders, we can write our own playbooks. We used to have playbooks, we used to have SOC workflows, but still it used to take us a lot of time because we had to go through a lot of noise, but not necessarily noise. Those were events of interest. Think about an analyst who is spending 8 hours of their day in front of their portal, triaging maybe 50,000 events manually or even in a semi automated manner. That can be compressed. The correlation across cloud or network or hybrid on premises and host endpoints is now much more efficient. Well, it was efficient with the XDR or MDR, but now you can write your own connectors or you can use the connectors which are built by organizations or vendors to just glue things together. Initially, we used to use Excel to write incident timelines. Later on, we started building PPTs. Now, that whole thing can be automated as well with AI based on the validated findings. And it can also distill technical information into executive briefings, which can then go on for any stakeholder relevant reports, which are often used after an incident. Now, before we get into the technical part of today's call, let's just take a moment to think about one TTP, let's say lateral movement. How would you detect lateral movement in a network? So, the common convention tells us that the detection approach would span across multiple logs, authentication, network traffic, process execution, Kerberos, and finally doing temporal analysis across the timeline. And finally, to do all of this, we would need to know a lot of event IDs. We would also need to learn about a lot of procedures that are used by the attackers or figure out what has been trending in the past couple of months or maybe even weeks. Some of this information is shared on Twitter or on Mastodon through relevant sources, through popular profiles, or through official briefings like CISA or DHS. Some of this also comes as knowledge from our internal red teaming. But to get to the bottom of something which has never been found before, we stick to ML-based analysis like statistical anomaly detection models or clustering and classifying models, which were there for the past maybe 7 to 10 years in all the products that we have used in our organization. But now things are truly changing. And to get a sense of that, let's quickly get our hands dirty into something that we can build and also see how it works. So I'll pause the PPT for now and I'll move on to my local system so I can show you guys what I've been working on. Just give me a couple of seconds while I pull things up. Right, so took some time. Laptop was hanging, but yeah. So before I get into the section of live build, just give me a thumbs up or a hands up to show how many of you do vibe coding as a part of your daily workflow or as a part of your hobby or as a part of your job. What I've done over here is created a small project for today. The whole point of this is to showcase how we use AI in our workflow. Now, the first part starts not writing the program, by coding it entirely. Over here, you can see that I have set it up using Python and Chainlit. What this essentially does is it acts as a preprocessor. I have a couple of logs which I have collected. There are some scripts. The last one you can see is upload Zeek logs to BigQuery. So I have set up two different places. One is Azure Data Explorer, which collects all the host and endpoint related events. And I've also set up Google Cloud BigQuery, which collects all the Zeek and network related events. Now, this goes to show that how a real organization, multi-cloud organization works, and not just that, how spread across the telemetry really is. On top of that, another thing that we wanted to do is be able to connect with these sources. For that, we have used MCPs. Now, I believe most of you are aware of what an MCP is. Can I get a show of hands? How many of you have worked with MCPs? How many of you have configured MCPs? So think of a way how two different systems talk to each other, right? Back in the day, API calls were the go-to solution. If you have a backend, you have a microservice, and they want to talk to each other, you have a database that also wants to talk to these two things. You built an API system for them to connect and talk. MCP is kind of similar because it allows an AI agent or an LLM to talk to something. In this case, that something is the data source. It is for us, it is Microsoft Azure and Google Cloud. And in these two clouds, we have configured, we have configured Data Explorer and BigQuery. So what essentially we are telling the AI is that these are the two different places where my data is stored, and this is how you should connect with it and how you should discover it. So let me see if I can pull up the MCP config. It should be here somewhere. Right. So this is a typical MCP configuration. You have servers mentioned, and you have two items that you can see. One of them is Azure Data Explorer. It has the link and URL to my cluster, and it has the name of the cluster that I'm using. It essentially is a command. Over here, you can see it uses UVX, which is a Python utility. And this is the name of the package. It's a Python package which was written by Microsoft. So this Python package uses these two environment variables, Kusto service URI and Kusto database, to connect with the data source that I have configured. Similarly, another block which is for Google BigQuery. This is again Python based. So UVX uses this package called MCP server BigQuery This was again written by the Google team. So it uses these two environment variables, which is my project ID as well as the location of the BigQuery database, and then connects to that particular database and does what the LLM tells it to do. Let me just quickly get back to my codex. What I want to show here is, let's take the system prompt, for example. Now, before I dig deep into the system prompt, let me just give you a quick rundown. We essentially have two things when we talk to an LLM. What we write is called as a user prompt. That is what we are giving as instructions. But there is also something that is considered as a system instruction, which is called a system prompt. Now, in this particular case, our agent is pretty dumb to begin with. So, giving it a bit of nudge and bit of direction, if you read through all of this, you will see it's pretty straightforward. It says that you are a DFIR investigation assistant. You are working with logs from these particular sources. It also gives a little bit of contextual information if you read through this and get a sense. Now, all of this is pretty much what you already know while working in an organization, right? Every time you join a new organization, you learn what are the different tools, what are the different ways to connect, how all these tools interact, and how I should correlate different things, or how I should, work with multiple tools to get my job done. And that is basically what we are telling this particular AI agent over here. Now, system prompt is something that keeps on evolving. When I started working on this demo, the system prompt was just 4 lines. You are a DFIR assistant. You have access to a host and network telemetry. You need to, correlate them, and you should be precise. You should always, uh, uh, you know, prefer hypotheses and statements that are testable and can be backed over something that is vague. At the end, you should summarize, basically giving it a general rundown. But over time, when I was doing my run or test runs before this particular webinar, I saw that it did not work the way I wanted it to, which is when I came back and added a couple of lines to naturally steer it towards the direction I wanted to go. Now, other than the system prompt, there are a couple of things called as skills. So over here, you can see there are 3 skills that I've created. Now I'll open up one of them so you can read them. Now, I explained what a system prompt is, and I also explained what a user prompt is. But skills are something which are very niche and specific. So if a person who is a fresher in cybersecurity has a general overview and a little bit of breadth of knowledge, uh, think of that as the system prompt, right? But as that person grows into their career and develops skills into a particular direction, think of that as the skills.md file. In this case, we are looking at a persistence hunting skill. This tells our agent that to be good at persistence hunting, what it should do, what it should focus on. A quick look at the file tells us we should be looking at some specific MITRE IDs. We should also be looking at some of the known and specific Windows security IDs and Sysmon IDs. We also tell it what are the logs and fields of Seek. We also give a very brief explanation of what normal feels like and what suspicious feels like and what should be the correlation strategy. Now, observe over here, there is nothing that talks about the personality or how it should act. That all of that was in system prompt. Here it's purely technical. Here it's purely to the point, and it tells this is what you need to know to be good at this particular thing. I'll also show you one more, let's say credential access. Again, over here, quickly you can see it just directly gets to the point. To be good at credential access, you should be focusing on these MITRE TTPs. These are some commonly known hosts. These are some fields that are relevant to us. Now, skills.md is something that you keep on building and you again keep on working on it and it keeps growing. But you might also ask that, hey, if I didn't do all of this, if I just picked a log and put it on Gemini, if I put it on ChatGPT, or if I put it on Claude, they would still work, right? Now, the thing here to observe is that these are frontier models. These are very, very large models. They have near about trillions of parameters, and they have been trained across a vast set of data. So they pretty much have that nuanced information, which a small model or a free model might not have, or a older model might not have. Uh, does these skills and system prompt follow a specific syntax or pattern? So, right. There are so syntax is, yeah, markdown. If you're writing it, you would write it in markdown format. Uh, Plain English, because LLMs understand plain English. The way to differentiate them is the way they are arranged. Over here at the top, I believe you can see um, there is a folder called as skills and skills slash skill name.md. That is our skill. And the system prompt is pretty much named system prompt.md. Now, when we call our agent, we specify these things. Let me pull up the script so it would be easier for you to see. Let's see if I can show it over here. This won't be a good view. Let me just open it up elsewhere. So here what you're seeing is the specific class which builds the prompt. Now, to think, these are multiple different things. User prompt is a different thing. System prompt is a different thing. And skills.md is also a different thing. But if you look at this particular class over here and the functions that I've written, that I've vibe coded rather, what it does is it picks that system prompt from the file, system prompt .md. It also goes to the skills folder and picks up the skills. It searches for the MD file and then picks them up. And eventually, what it does is it joins all of these sections into one particular big chunk of text. And that big chunk of text is what goes to the LLM. Because LLM does not have multiple input points, it just has one way to accept an input. But when we write or when we develop AI agents, we make these distinctions that this is a system prompt, these are multiple skills, and this is our user prompt. So let's quickly go to the next thing. Great. Also, while working on this, what I found is that there are cases when the LLM that we want to use is unavailable. So in that case, what I've done is I've also added an edge case that, hey, let's add a fallback. So we can have Grok, we can have NVIDIA, we can have Gemini, we can have any of these vendors, and we can configure any of the models that we wish, so that if any of them fails while it is reasoning or while it is working, the script or this agent can switch over quickly to a different LLM. And with that, I think we are good to go and take a look at the app. But before that, let me also show you how this works and how this looks like. Let me just quickly clean up my terminal and share that. Right. So this is where the script exists. So this is where the script exists. Uh, what I have created. I had I have skills .md over here. Let me also show that to you. I have these three skills: credential access, lateral movement, and persistence. I have the system prompt in the root directory, and I have also kept the MCP configurations in the root directory. And I've also configured my environment variables that are required. Now, main.py is my entry point, and it goes into the app directory and pulls out the app. I also had a couple of scripts written because I had to pre-process some of these files. So, for example, if you take a look at, let's say, the Z directory, I had some examples. Let's say, yeah. So these were some of the log files. Let's see. So this was the connection.log from Zeek. One thing that you can observe over here is the field names. For example, the field name for source host is id.org-h. It's the same for the destination port or the destination host. The problem here is while sending these logs to BigQuery, BigQuery does not accept fields which have dots in the name. So then what I did is went back again into writing a small script, tidying it up, cleaning it up, so that we get a much cleaner version of this particular log. So just to give you a view of how that would look like. So this is the cleaned up file. It does not have the dot in the field values, which is again thanks to a script which we had. Let me also give you a glimpse of how that looks. Right. So this is the script, and the key point to notice over here is at the top, which has a replace. Everywhere you see a dot in the field name, you replace it with underscore. And there are a few more things to tighten up as well as the main function that exists. Okay, so now all of these are out of the way. Let's go and boot up our application. So the way to do it is because we're using UV run chainlit. The application is written in chainlit, and then the entry point is main.py. This would spin up a browser window. So let's just quickly go to that. But before doing that, it would also run a couple of pre-flight checks, such as, am I able to connect with the data sources? Is the MCP configuration right? So yeah, it's booted up. Let me take you to the browser. Right. So as I mentioned, what this does is it connects to the data sources. Make sure that the data source is up and running. The databases, the tables, the rows, all of them are accessible because we don't want any errors. Yeah. So, it got an error. What is this? Unpack non-type literally. Okay. So the error is only with Azure Data Source. It's not with Google BigQuery. What we can do is we can simply reboot the application because this looks like a one-off thing. Let's just kill it and start it up again. Okay, seems like there is some issue uh, temporarily with connecting. So no problem. We'll go back to our fallback. So before the call, I did a run. Let's go and take a look at it, walk through it. So the pre-flight is basically connecting to the data sources that I have, and it checks all of the tables. Now, once all of that is ready, you should get a message that says DFIR assistant is ready. It has loaded all the system and skills. MCP tools are discovered, and everything is good to go. So now comes the real thing. Uh, it is very similar to the situation where you are at your desk at the start of the day, at the start of the week, and you want to make sure what should I do. So this is the prompt that I've given. Like, what log sources and telemetry do we have access across ADX and BigQuery? And finally, summarize the tables, the event types, the time ranges available, all of that. Now, this is a pretty standard thing I think most of us do to get a lay of the land. We look at the volume, we look at the types of logs, categories, and events, all of that. Now, if you take a look, there is a lot of things that is going on over here. Tries to get a sense of the table schema, tries to execute a query against BigQuery to get all of those data. It pulls everything out and then gives you a summary. That okay, so ADX contains the host telemetry, it contains um, all of the host level data, there are a couple of tables which are relevant to some PS execution, registry modifications, scheduled task creations, SMB events, and it also provides us the time ranges as we had asked. Next up, it talks about the BigQuery, and it has rightly identified that BigQuery contains network telemetry. There is a data set called Zeek underscore logs, which I had created, and it contains a couple of tables. The most prominent ones are listed over here. Con for connection, DCERPC, Kerberos, NTLM, and SMB mapping. Now, these are again those same logs that I had captured from running Zeek on packet captures. They are uploaded into BigQuery. Now that we have this first set of information, the next prompt would be to get a sense of what is going on. So the first set of hunt that we would do is hunt for lateral movement techniques across both the host and network logs. Let's look for the remote service creation, anything related to PSXX style execution and SMB based movement. And we'll also ask it to correlate with the DCERPC service control calls, SMB share access, and connection patterns in the network data. Also, since we had the time range, we had provided it the date and the time window to look at. Again, you will see a lot of tool calls across the MCP. This one is in Azure Data Explorer. This one is to the BigQuery. It runs a lot of queries in order to gather the context and then finally answers. So this is a great find. I have queried the SMB exec table again. This time I had broadened my time window. I found a cluster of activity at so and so date and time. This is a different time than the network events, but the activity is highly suspicious and warrants further investigation. It tells us the key evidence, service creation. The service name is random junk. It is a strong indicator that it could be lateral movement from PS exec or SMB exec. It also found obfuscated PowerShell, uh, and it also found who am I execution, and it also found the relevant usernames at that time. Finally, it tells us connecting the dots that the timestamps don't add up, but what it tells us is consistent communication between two hosts. And the revised hypothesis is the network and hosts are likely related, but there may be a time sync issue, or the attacker may have performed these actions at different times. Finally, it tells us that the combination of randomized service names, obfuscated PowerShell, who-am-I execution are all strong indicators that a hands-on keyboard attacker is conducting lateral movement. It also gives us a couple of next steps to do, which is pretty good. And finally, it gives us the entire big chunk of base 64 PowerShell that it had found. Now, one thing to notice is how easy it is to go from an idea with a prompt to a definite finding. Now, since I was unable to show you this live because of some temporary issues with the MCP, it usually takes a couple of minutes, not minutes, just roughly around 1.5 to 2 minutes, because the first the first prompt had a lot of tool calls. So this would go on around maybe 2.5 minutes. But the next one is more about figuring out specific queries. So that is why the number of tool calls are less. And it was about 1 to 1.5 minutes or just under 2 minutes. And then it gave us this big finding. Great. So Moving on, the next prompt that I had is for any lateral movement, trace the full chain. Which host initiated the movement? Which host was the target? What credentials were used? And what DC/RPC operations were executed? Also check for any Kerberos or NTLM logs for authentication patterns. Now, just by looking at these three prompts that I have given so far, you would relate it to how somebody in your team, like a senior or probably a manager, would talk. Right? They want to get the bird's eye view of all the different things. Most of us spend our day writing the nitty the queries and figuring out the smaller things. This is the beauty of building something of our own or something that already exists in our organization, which is LM or an AI, is that you would also think from a bird's eye view, your prompts, your skills, all of these configurations drive that technical nuances and then finally give you a report which is very easy to understand, very easy to dig down, and easy to share. Now let's look at what is the response over here. Again, you see one MCP tool call. This is pretty quick because it already has a lot of context from the first two. So now it just does one query. It gets there's one SQL query to BigQuery, and then based on the output, it says that excellent. I now have correlated the network and host data. These are the chain of events. This is the initiating host. This is the target host. These are the time ranges, and the credential used are of this particular user to authenticate from this host to this particular host. Now, what are the detailed steps of the attack? At first, authentication occurred using NTLM auth. Then we see a lot of SMB and RPC connections connecting to the IPC dollar share on this particular host, which is a very common vector for SMB exec or PS exec attacks. Then we see remote service creation, which again is observed from the network telemetry, the packet capture, because we see a lot of DC, RPC operations over there, including the open service control manager and create service. Now, these are all functions part of the DC, RPC operations, which we can observe when we are looking at packet captures or network telemetry. So far, it has confirmed that a remote execution has happened or a remote service creation has happened. And finally, host level logs, which are stored in ADX, Azure, tells a very similar story that service was installed. It had a very weird name. And a process was also created. Why? Because the service spawns a CMD process with base 64 encoded PowerShell commands. And it runs as with higher privileges of anti-authority system. Finally, it executes who am I as a child process, which is part of post-attack recon. Finally, it gives us a summary of what it had found, and the confidence level is pretty high. It also gives us the rationale. Now, whenever we are talking to different people in our team, let's say there is somebody who's new in our team and they want to ask, okay, why did these three things make sense? And why are we even correlating them? We would often tell them that, okay, this is the rationale behind our investigation, or this is the rationale behind our conclusion. The same thing LLM does for us. In case we want help connecting the dots, or if in case we want help understanding something which is a bit difficult or a bit confusing at times. So LLM would use its typical reasoning tricks to get you on board with whatever it has found, but that doesn't necessarily mean that it is doing a good job with explaining things. Which is why in this particular example, you will see I'm continuously showing you all the tool calls and all the queries that are running over here. Why? Because suppose this particular product is used in an organization and you doubt that maybe the AI is trying to fool me. You would simply copy this query, go on to your product. It could be Elastic, it could be CrowdStrike, it could be Splunk, it could be Azure, it could be AWS, it could be Google Cloud, anything. Whatever query is being made by the LLM through the MCP tools is copy it out, go to that product and paste it and run it and verify that does it match the output that the MCP tool and the LLM has received. It's going to be 100% correct. If not, something is going wrong. You might want to check the prompts, you might want to check the query that the LLM is making. In that case, you would fix the system prompt and steer things, or maybe you want to fix the skills trend to steer things to the right direction. Okay. Now that we're out of the way, the final prompt here is generate a complete incident timeline from all validated findings, include the attack chain, MITRE attack techniques, confidence levels, and also recommend the next investigation steps. Finally, format it as a stakeholder ready summary. So think of it as a proper report, and that's what we can see right from the get go. A good heading at the top, date, confidence level, a bit of executive summary, then detailed timeline, gives a good brief of timestamp, source host, target host, what was the action and what was the evidence. In this case, the BigQuery database is the evidence. In this case, again, BigQuery database. And then finally, this evidence is pulled from the Azure Data Explorer. A nice table. And then we see another table for MITRE attack mapping. So all of the things that it found, lateral movement, it found execution, it found defense evasion, it found privilege escalation, it found discovery. Now, the description really helps because based on the prompts and the answers, we know lateral movement happened. Uh, we know discovery happened through who am I. Privilege escalation makes sense because you're using one username on a different host, but it did not mention. Oh, it did mention the service creation that escalated privileges to system. So yeah, this makes sense. Defense evasion, why? Because base 64 encoded PowerShell was there. And execution, simply because PowerShell was executed, you are able to execute something on a different machine. So yeah, all of these check out, they make sense. Key uncertainties and investigation gaps. So the LLM was not able to figure out what was the initial compromise. How did this uh, attacker get in? What was the intent of the payload? So right now, this particular agent did not have the ability to decode the PowerShell base64. It that is pretty easy to solve. We would just add another MCP tool or a function call, let's say, to one of our safe Linux environments, and tell that hey, you have access to all the Linux command line items. Uh, Go crazy with it, and the LLM would simply do base64 decode and figure out what the script was. But anyways, another uncertainty was what was the further activity. We don't have enough logs to look what happened after. So we have a small glimpse of lateral movement, privilege escalation, discovery, execution, all of that. Then it also talks about the recommended next steps, which is decode the PowerShell, investigate the source host, and expand the host analysis to the destination host. And then finally, do a dedicated analysis on this particular user who has been running these commands. And yes, that's pretty much it. So, in just four prompts, we went from what is the lay of the land to what is the incident report. We did the live demo, and yeah, now that you saw how easy and simple it is with a couple of prompts, a couple of skills, uh, and a sample data set to go from what are we working with to what is the incident report or the threat hunting report. Uh, it might raise questions in your mind that okay, if AI is able to do so much, then what should I focus on? And that pretty much is what doesn't change. What doesn't change is the hypothesis that you drive from yourself. That comes with your own experience and from your own intelligence gathering that you do on your day-to-day life. Uh, Validating the evidence that you're looking at. you would always question your work, and you would also question the work your teammates have done, right? Because that's how healthy peer review works. Similarly, you should not blindly trust the output that your system is producing. So uh, just do a peer review on that as well. What one thing that you would have also noticed, the system prompt and the skills.m, I have consistently mentioned the MITRE attack framework because really for us humans, but it's also for the AI agents to really bring things into context, categorize them, and grow it while it's doing its own job. And finally, uh, communication soft skills are really relevant. They don't change even if robots take over. That still pretty much stays the same. Now, what's next is the course, which starts at the end of this month in May. Uh, the screenshot is old, but you can go on to the InfosecTrain website and take a look at the dates. I believe they are 28th or 29th of May. What you would get a glimpse of in that is across 10 modules and across 40 hours, we dive deeper into how we can build our own lab, how we can build our own AI agents, how we can build this entire workflow and automate a lot of the hectic work that we have been dealing with. Really focus on compressing the time without compromising on the investigative quality. Now, if that sounds interesting to you, I welcome you to explore this. Get in touch with the folks at InfosecTrain, and we'll get to know each other in the course. I often get a lot of questions around how the future looks like, even without AI. It's pretty straightforward for beginners who are there on the call. Uh, you might already have done a couple of certifications, but the importance does not change. They still provide a good ground for you to learn and grow and validate what you have already achieved. So consider them based on your area of expertise, your skill level, and to which direction you want to take your career in. Right. And these are few more things that are right now there out in the world.